Hi. For the today's YouTube video, we're going to discuss about couple of system design architecture. So, I want to explain how the system design works in software industry. So, software development life cycle. We know that whenever we want to build any application, so we follow the software development life cycles. There are some methodologies. So, in the initial phases, all the stakeholders, the clients and the developers, team leads, project managers, product managers, they all concentrate on the system requirement and what is the requirement of client and what are their expectations. They'll come up with the the design documents for particular requirements. You see, they'll come up with the high-level conceptual design documents. They'll come up with the conceptual architecture. They'll see all the feasible solutions before they're jumping into developing the actual application. So understanding the system requirements and client requirements, business requirements is very important. They have to look at all the scenarios. They need to find out if any risks are there. If any risks are there, how can they mitigate those risks? What is the complexity of the system? What is the feasible? What is the MVP feasible solution? So, in order to build a sophisticated system, it is very important to make sure and understand all these things. I just want to explain in high-level system design. So, most of the systems, they are distributed. They are not client-server model. Most of the systems nowadays are distributed, as we can have a client-server models. But the thing is, you see, depending on the load of the application. So business, the business requirements are nowadays they are more of a multinational. So I see if they want to do a global business, so it should be compulsorily distributed system design architecture. They should adhere to the distributed system design architecture. You need to keep in mind, whenever you are designing distributed system, you need to have a proper load balancing mechanism based on the demand and capacity. The load balancers, the servers, they'll scale your backend services or backend components. So you can scale the instances of the servers or applications of any component, using a load balancer. So load balancing mechanism is required to handle the load capacity that is coming as part of the traffic. Load balancers are very important. I need to build a fault tolerant systems. Whenever a system is failed, there should be another fault tolerant mechanism to serve the particular request. So you need to build fault tolerant systems. Okay, you need to have another instance. So if some instance goes down, there should be another instance as an application or service should be available, a database component. And you can also use the messaging queues because nowadays most of the system design architectures, they are following event driven architecture because they want to do the things instantly. When we talk about synchronous systems, so there are some problems, right? If it is a system application is very complex, if it is having a lot of microservices and you want to establish a communication among multiple services. So if it is a synchronous approach, synchronous communication, so definitely it will take time for the system to process the communication among multiple services, and the latency will be very huge and it may hit the performance issues. So sometimes you need to take care of these issues by introducing event driven architecture. It's a kind of hybrid model. You will have some things are asynchronous approach, and other components may coordinate using asynchronous approach. You need to build like that. So that is one of the factors of the system design. The databases, yeah, you have to choose the right database for your requirement. We have a relational databases and non-relational databases, and graph related database. What is the business requirement, and is it a banking application? Then you go for a relational database because you want to follow asset properties. So you want to enforce some constraints, relationships. So then you need to have a databases which stores the data in atomic level. They'll follow some constraints. Data will be stored in the rows, columns and rows. So it will be very easy for banking application, financial institutes to process the data, to process any transactional data. It is very important. And if it is a kind of social media application or kind of e-commerce application where the speed is only factor for your requirement, you want to store an object, and the data is also is not a structured. Sometimes it may be unstructured, semi-structured. Let's say if you take any social media applications, Facebook, or you take any other social media application, generally users will post a lot of messages, lot of data, and the posting message always is not a structure. It is dynamically changes. The schema dynamically changes, right? We don't know how many fields will be there. So then we need the NoSQL databases. So its purpose is just to store data as an object and get the data as fast as it can retrieve it. So that is the expectation. So NoSQL databases basically used when you want to deal with unstructured data, semi-structured data, and fast retrieval is your expectation or factor. Your expected scenario. Then you can choose for NoSQL databases. NoSQL databases are very good when you want to deal with unstructured, semi-structured data, and speed is your factor. You want to retrieve the data as fast as you can do, and you want to display the data there. And the database schema is also dynamic. You don't know how many fields or how many properties will be stored for each user. And if these are the situations, you just opt for the NoSQL databases without doubting. So that is about databases. And caching is a scenario. I already spoke to you. We'll have different clients, right? We'll have banking and financial institutes as a client, or we may have e-commerce applications, we may have social media, entertainment, healthcare related. So the caching is required when you want to store very frequently accessed data but non-sensitive data. There are two conditions you need to keep in mind when you want to use a cache. So you want to store very frequently accessed data, and the data should be non-sensitive. It should not be very sensitive. Sensitive data means the customer may have demographic information, cards related data, payment related data. You should not store this data in the cache if it is very sensitive, and also it should be very frequently accessed data. You take if you take frequently accessed and which should not be updated very frequently. The data also should not be updated very frequently. See, if the data is getting updated very frequently, and if you are storing in the cache, and you may need to hit the databases every time, because data will get updated every time, right? Then there is no point of using cache scenario mechanism here. You need to keep in that mind. So it should be very frequently accessed data, and it should not be updated very frequently. These are the conditions, and it should not be very sensitive data. Okay, very sensitive data should be stored in the database, encrypted at rest. So you need to follow these things, follow these practices when you are building a system design. Okay. and you have to handle the traffic properly. You have to store the data. You can apply the encryption at rest. Okay, and the process, we can actually process the number of requests. Okay, number of requests, how many requests your application wants to process, what is the expected traffic for a particular application. These are all the business scenarios, requirements. We need to list down, and we have to ensure the reliability. The system should be reliable. Even if one server down in one particular region, another server should be able to serve, the nearest server should be able to serve the traffic. Okay, we should not, we should make sure the SLA is almost 99.99% uptime. Otherwise, at least 90%, even for startups. Then only the applications would be more reliable. Otherwise, it would be a problem. Okay, so you see, this is what I just wanted to explain in the high level. These are the system design things, and I want to explain other thing as well. Okay, let's see some of the system design architecture. Okay, we don't require it. And see some of the system is an expected passing system. Okay, we will see some of the system design. Okay, we're not talking about, we want to see the system design, not about system architecture design. So you can see here system design architecture, simple system design. We are having a CDN and DNS, domain naming server, CDN for content delivery network. You have a API gateway, and after that you will have a backend servers, and the security is also priority for you. You can see this for security purpose. You can use authentication and authorization servers. Content delivery network, you want to store the static data in content delivery network servers, so that you can fetch the static content very fastly. And DNS, domain naming server is required, so you can map your host details for the keywords, any professional website name. So domain naming server, so when you type a particular website, right, the domain naming servers will be able to identify the host IP address. They'll actually reverse engineer your the website name into the IP address, and they'll find the particular host details. Okay, and the caching mechanism, as I told you, you need to cache the data. This is a simple system design architecture, but it covers most of the things. You can see these are the high level things. I mean, we will always have these systems in a particular system design when we are designing a system, and we have a system, so multiple servers are there. Okay, and you can see here, so this is another kind of system design. You can see we have a web server and database server, and schedule server. We are scheduling some data, some campus network. You see, we have some other servers. You can see it is a simple architecture for another. Okay, let's see for another designs. Okay, here you can see we have a gateway, right? There is an internet, and we have a couple of servers. Okay, let me pick a proper system design architecture. Okay, I already stored some system design. Let me already download it. This particular okay, this one. Okay, I want to explain this template. You can see it is almost explaining each and every component here. So we want to start with this DNS. This is system design, domain naming server. You can see whenever client hit any website URL using a domain naming server, we can actually it actually converts that particular website address to identify the respective IP address of the particular application. Okay, so and content delivery network, as I told you, we need to have a content delivery network for storing static content. API gateway is required, where we configure all these load balancer, rate limiting, cross-cutting scenarios. We will configure at API gateway. The first request comes to the API gateway, and here we actually authenticate and authorize the request, and after that we will route the request using a load balancer and also a rate limiter. Nowadays we're actually facing distributed denial of service, right? Hackers actually fire the number of millions of requests for particular application to make the system overload. That way they'll try to hang the system. So to avoid that problem, we need to configure the rate limiter. Using a rate limiter, we can actually specify the application, how many requests can be processed per second, how many requests can be processed for a particular user. We can actually specify all these details there. The web servers are there. You can deploy your user interface application separately in the web server. Nowadays most of the companies are using a separate web server for deploying their user interface in web server. And application servers are useful when you want to deploy application servers into there. Okay, you're getting my point, right? Now you see the security, authentication, authorization. Security is very important. We can use the authorization servers, authentication servers for generating JWT tokens, or for authenticating particular users. We can use any third-party authentication mechanisms using WAUth services. Okay, so you can configure the authentications. We have application service. You see, compliance service, you can generally configure all the policies, rules, regulations of particular business, and the compliance servers will run against those rules and make sure that particular user request, they are following the compliance of the company. Configuration service, you can actually provide configurations. Okay, distributed ID generator is required. For each and every request, you need to generate a separate ID in a distributed environment. So this is very important for generating a specific unique identifier for a particular request. That way you can track all the requests properly. And you can see backup. Okay, we have a shard manager for database. Database sharding is required because As long as you are using application for longer time, so the database becomes very huge. The database data will become very huge. Then you need to shard the database to improve the performance. So sharding is required. So you can actually shard the database with multiple snapshots you can see here. So you'll shard the database tables into different copies. That way you can increase the performance. So database sharding is simply, there is a table, it's having millions of records, and you store some records in one, some records in a database of other table, database same table name but different database, and some records, you will split all these records. There are million records. You will split those records into three parts. There are number of rows. You take from record 1 to record 1 to 10 lakhs records. The first 10 lakhs records you store in first database. The next 10 lakhs records you store second database. So that way you split them using a range. Because when you hit the URL, based on the request ID, database will be identified and you will fetch the data accordingly. Okay, and we will use a hashing key mechanism where it will identify if any request is coming for particular user ID. So based on the hashing key, will identify where that particular record is stored in the database for a particular user. That way we will fetch the data. Distributed cache, we can use a caching mechanism, reduce each cache, second level caches for Hibernate, you can configure it. Persistent database layer, you can use NoSQL database, NoSQL file systems. You need to take the replicas of the database or the mirror databases for the safety purpose. And backup and recovery, taking a backup of snapshots of the databases would be useful in production. Sometimes whenever some crashes occur, you want to recover the database, you can recover it. Using a PubSub options or event-driven architecture, you can also apply, as I told you, notification module, alert mechanisms. They'll all be handled by using this event-driven architecture. Task scheduler would be useful for you. You want to schedule particular tasks as per the schedule. Earlier we used to have a cron jobs, and now there are predefined task schedulers are available. You can simply build any workers, and each worker will perform certain task, and you will submit all these workers to task scheduler. Task scheduler will schedule the worker nodes. And you can see for analytical purpose, we can have recommendation systems, elastic search engine, MLAI engines. We can actually analyze the data, we can process the data, mine the data. We can store the data in data warehouse systems, and after that we can mine it. Okay, and for payment system also. So these are the things. Hope you understood this video. Thank you for listening.